So my name is Karol Gugala, and I would like to talk in short, because I have only 20 minutes, about Zephyr and Zephyr's cloud connectivity and how Zephyr can actually help you to build a distributed IoT system with cloud in mind and with the whole system arranged around cloud processing. I'm from antmicro, and we've been here for quite some time. We are Zephyr members, Platinum Zephyr members, and we use Zephyr and cloud technologies to build various of products for our customers. So when we look back at how IoT and cloud with context of IoT worked in the past, it was basically built in a way that the nodes were pretty simple, pretty dumb, and the only thing that they were supposed to do is to just collect the data and push it to the cloud without any thinking, without any processing, just at all costs, just move it somewhere else to process it on like more bulky machine, on some more powerful machine. This unfortunately ended in like not really good experience for many people. There were a bunch of like custom implementations, not really taking care of security, of safety, and robustness, and some standard, and so on, so on. So fortunately, that is changing. That is shifting, and the nodes are getting like more complex, more standardized. They can do more. They can also process the data. And like if you look at what's happening in IoT and this cloud connectivity between nodes and more powerful machines, it's becoming more and more like balanced. There are the nodes itself, they can do more. They are more responsible for doing more of the processing. But it doesn't mean that cloud is unnecessary right now. So the cloud is still there. The cloud is the backend for users, the backend for processing the data, the backend for getting the data and processing it is still there, is very important. And there are many providers of those. There is, of course, many nodes that produce the data and many ways to connect it to each other. So basically things like making the whole connection, making the whole system secure, robust, and scalable is even more important than previously. And Zephyr, if you think of it, Zephyr actually provides a lot of building blocks that makes it way easier to build a modern, robust, secure, scalable system. That's because of its the universality, I would say, that there's a word like that. That's because it's non-tied to any single provider, any single vendor, like hardware vendor or cloud provider vendor, because it implements many standards and implements many tools around, like, for example, SBOM, software BOM, that allows you to easily track whatever software components were used to build the firmware running on the device, which is really important in the end because you can easily track if there are any holes and there are any vulnerabilities in the system. So if you think of connecting a node to a cloud, there are typically two ways to do that. I mean, probably you can come up with more, but there will be more or less permutations of those. So you can connect a node directly to the cloud, where every single node is responsible for handling the whole authentication, authorization with the cloud, handling the whole network partitioning, handling congestions. It can reuse some existing infrastructure, like for example GSM network and things like that. It will probably use some more networks with higher throughput, like for example GSM, like Wi-Fi, like Ethernet, if it's a cable node, a cable connected node. And then to just report directly to the cloud. The other way of building those networks is building a gateway and like a network of some nodes that talk to each other, They can even create a mesh network, so every single node don't have to be in range of the gateway. They can communicate with each other and just report to a gateway. This has, of course, some pros and cons. I mean, the nodes can be simpler. They just report to a specific gateway that can be like wall powered. It doesn't. I mean, the gateway don't have to really, save the energy. But the drawback of that is that you may need to implement. Sorry, you may need to implement for example, this mesh routing and things like that. So let's first talk of direct node connection and how Zephyr can actually help you building that kind of a IoT network and that kind of a system. So first of all, if you would like to start with Zephyr and see how it works, there are already examples. If you go to Zephyr repository, clone it, you can find examples. I will show them in the next slide, but you can already find that there are examples just ready to use. Just build them, run them, and see how they work. But if you'd like to just build your own setup, you can choose from variety of network interfaces that are already supported. So just to name a few of them: Ethernet, either IPv4 and IPv6, Wi-Fi, GSM. I mentioned them before. Also some like higher level protocols like MQTT, which seems to be the protocol that is actually right now used by most of the cloud providers as the interface for feeding the cloud-based system with data. Co-op to some extent can also be used for communicating with the cloud servers. It's not that widely used as MQTT, but it is supported. And the examples I mentioned there are actually 3 of them already in the Zephyr repositories. So there's Google IoT MQTT sample, Azure sample, also MQTT, and Tago.io Cloud HTTP sample. Unfortunately, the first one, the Google IoT MQTT sample, will probably need to be like either re-implemented or like extended with exchanged with some other sample, or just dropped because Google is retiring Google's IoT subsystem like next year, in August next year. But the rest is still there. That you can for now you can of course use all of them. So you just get them, run them, and you will see how they work. The other type of connections is, of course, as I said in a few slides back, nodes and a gateway. This is the connection where you just put a gateway and connect nodes. In most cases with some kind of a mesh networks, and Zephyr here can actually give you quite a lot because it implements a bunch of apart from the interfaces that you just mentioned, like Wi-Fi, Ethernet, and GSM. It implements quite a lot of those low energy and basically dedicated for IoT interfaces like Bluetooth Low Energy, Mesh Bluetooth Low Energy, LoRaWAN. This is this wide area protocol for like smart cities and things like that. IEEE 802.15.4, so those low power IPv6 protocols for wireless communication. OpenThread mentioned in the beginning, in the first presentation, that's been a thing right now and being implemented in like home automation systems. On top of that, you can access those interfaces with like of course some higher level interfaces like plain BSD sockets, as you would do in Linux, but also co-op MQTT, as I said, one of the most popular right now. And there is even a Matter support in progress. There is a PR pending and quite a lot of discussions about it. So soon we should probably have also Matter support in place. Besides, of course, having the way of communicate, one of the most important aspects of getting the nodes and communicating them with the cloud is security, and not only the cloud, but also with each other and with any gateways. Is security, and again, there was quite a few examples, quite a few things about that in the previous two presentations, but just to have them here, list them here. Zephyr also provides you with like embed TLS support, which you can use for just securing the connection, securing the data exchange between the nodes and the gateways, and of course the cloud itself. Yeah, so that's pretty useful, and that's pretty important in the end, because there is the saying that S in IoT stands for security, and it shouldn't be true. We should have a secure IoT, and Zephyr can help you with that. So that's when it comes to software. There is a bunch of building blocks you can reuse to build your software, but software needs hardware to be run. And one of the advantages of Zephyr is that it actually supports quite a lot of hardware, more than 400 boards right now. So if you want to build an IoT system, like a distributed system connecting to the cloud, you can start with very different hardware and just choose the best. And by support, Zephyr supports things from things required to building like a single node, a bunch of simple nodes, but also things to build a block that can be used to construct like a gateway, like more sophisticated device, or can even be run on like a production-ready device, like for example this large system gateway, IoT gateway. We, as antmicro, we built this small board here. I probably don't see that. This is my cursor, but the one at the bottom. This one can be used to build, to like connect to a bigger system, Linux-based platform, and just provide IoT connectivity, like with a Nordic chip with an RF microcontroller. If you're interested in all the boards, you can just follow this link that I pasted at the bottom of the slide, and you will see the list of all the boards that are available and supported in Zephyr. So if you have like a number of devices that are connecting to the single place, to a quite powerful machine where you can run very sophisticated software, you can think of fleet management. Piece of software that keeps track on every single device, on every single node, can update it, can check whatever state the device is, and basically figure out what's to do with it. So Zephyr again provides some functionalities that allows you and enables you to actually implement this functionality. And this is like from bootloader itself, like MCU boot, for example, that enables you a secure boot that can choose between different images and boot whatever you want. But also, the standardization of like a build process, of linker script, of how the software is placed in the flash, makes it way easier to actually work with such a system. There are even some third-party providers that can give you systems like that. I listed 3 of them. They are the systems that I list here. They mostly work in a way that you have like a either open source or source available client that you can link with your application that runs on a node, and some proprietary backend, proprietary server to which you can connect and use it as a service. And having all of those devices, having this cloud and even this cloud system and fleet management system, is great. You can deploy various software, you can manage it, but it still requires some testing. And again, Zephyr's configuration and Zephyr's the way Zephyr is constructed makes it way easier to actually build an end-to-end system that can be tested, an end-to-end test system that can be spawned on multiple machines spawned in the cloud, and just test various scenarios, like various hardware configuration, various connection configuration, like inject some faults in the communication and so on. Just be sure that you whatever you deploy is tested, will not break the system, will not break anything like that. So if you think of Zephyr, And if you think of what infrastructure it provides, it's really great thing to start building your IoT cloud-connected networks. That's because you can use a bunch of standard building blocks. You can simply get them, connect them, build on top of that, and you don't have to reinvent the wheel. If you'd like to check whatever is supported, whatever works, we some time ago built something like something called Zephyr dashboard. So if you just follow the link here, you get to a page where we list more than 400 Zephyr boards that are automatically built and tested in the cloud in an emulation system, where we check whatever they work, whatever they, how they work, whatever the demos work, and so on and so on. And if you click on any of them, you get to a web page where you get hardware information about the platform they run on. So this is a great source of information about supported hardware, supported software that can run on it, looking at the traces, looking at whatever is there, whatever components are there, and so on and so on. So if you plan to build distributed IoT system based on Zephyr, this is a great source of information. Just go there, see whatever is there, whatever works, and how you can utilize that. So if you'd like to read more or watch more presentations about cloud connectivity and Zephyr, I pasted a few links. Of course, those presentations will be probably available somewhere, so we will be able to click those links. The first two are to this year's and last year's cloud tracks of Zephyr Development Summit. The third one is to Renopedia, the place where you can check the boards, the hardware configurations, and so on, to just find the best solution for your future use cases. Thank you.